Okay, intermediate algebra. This is lesson 13.4 and it is called geometric sequences. Now in 13.3 we did arithmetic sequences, and if you remember arithmetic sequences, if you look back on page 757, it says each term is obtained from the preceding term by adding the same amount. So, for example, just as a reminder, if we have this series of numbers, or this list of numbers, 2, 6, 10, 14, how did we get from 2 to 6? We added 4. We added 4. We added 4. That's an arithmetic sequence when we add to get to the next number. Geometric sequences are the same, only we multiply to get to the same number. So we multiplied by 2. Multiplied by 2 times 6 to get 12. 2 times 12 to get 24, and etc., etc. So that's the difference between the arithmetic and the geometric sequence. Alright, so there is a number, like when I had 3, get my pen to work, 3, 6, 12, 24. Okay, so I multiplied by 2 to get 6. Multiplied by 2 to get 12. 2 to get 24. This number right there is called a common ratio. So common, sorry about my writing. Okay, so that's one of the important parts that we're looking for, is we're looking for what's called the common ratio. All right, in order to find the common ratio, it's a pretty simple method here. You just take two of the numbers. So let's go back to my 3, 6, 12, 24. To find my common ratio, I just pick any of the two numbers that I have up here. So let's pick these two. And I write it as the second number over the first number. All right, so the 12 over the 6, and I get 2. That's my common ratio. That's the number that I multiplied by each one to get the next number. So another example would be as if I had 1/2, 1/4, 1/8, 1/16, and I wanted to find the common ratio. I just take two of my numbers, take the last one, put it on top over that one, and when you're dividing fractions, you invert and multiply, and we get 8 over 16, which reduces to 1/2. So that's my common ratio. Okay, and that is symbolized with the letter R. So lowercase r, you would write 1/2. That's the common ratio for that. All right, so what are we going to do with all this? All right, if I have, well, let's just look at one more example. 3. Let's start with the square root of 3. 3 square root of 3, 9, and then that just goes on forever, and I want to find out what R is. I just grab two of these. And it's the square root of 3. That's my common ratio. Okay? So not too hard. All right, so there is what is called a general term. A general term is basically, there's this formula out there that you can always find any of the numbers. So like, for example, if I put 3, 6, 12, 24, and I said, you know, this goes on and on and on forever. I wonder what the 100th number out here is. If this is 3, 6, so I've got the first 4. What if I want to know the 100th? Well, I use this formula called the general term formula, and it will be able to tell me what term or what number is anywhere down the road there. So that general term formula is A of n equals A 1 R of n minus 1. Okay, this is an exponent, the n minus 1. See if I can make it look a little more exponent-y. There. Okay, and this n right here represents the term. This represents the first term. This represents the common ratio. All right, so looking at that information, let's kind of play around with this for a minute. Okay, so for example, if I have 5, 10, 20, and this goes on and on and on, I know that my ratio is 2 because I multiplied my 5 times 2 to get 10, my 10 times 2 to get 20, etc. So I know my R is 2. I know my first number is 5, and that's what this represents. That A1 means my first number. Okay? And what is it asking for? Find the general term for the geometric progression. So what it's asking me to do is rewrite this formula for this problem down here. So I'm just going to fill in some blanks. I don't know what my n is. We'll look at that later. I know my first number is 5. I know my ratio is 2. And that n minus 1, I don't know what the n is, so I just leave it like that. Okay? So right there is my general term. I just took the original formula and turned it into a formula that works for this particular problem just by putting in the first number and my common ratio. All right, so let's look at some other directions here. And I'm going to go ahead and write that general term formula up at the top here so we don't forget it. A to the n power equals a to the 1 r to the n minus 1. Okay, we're going to keep that one there, and we're going to look at example 4. And it says find the 10th term. So it gives me a sequence. It gives me 3 halves, 3 fourths, and 3/8, and it goes on and on and on forever and ever and ever. And it wants me to find the 10th number down here, whatever number that is. So we're going to use this formula that we have right here. So it's looking for the 10th number. That's what the n is. The n represents which number we're looking at. We're looking at the 10th one. So I'm going to put a 10 there. First number is a 3. And what is the ratio? Well, let's grab two numbers, divide, or multiply by the inverse. Okay, and that ends up being 12 over 24, and that reduces to 1/2, right? Okay, so that's my r. r is 1/2. And n, what did I say n was? N is 10 minus 1. So to rewrite this again, I've got a to the 10th equals 3 to the 1/2 to the 10 minus 1 is 9. Okay? And then I have to solve that. So I get my calculator and I put in 1/2 or 0.5 to the 9th power. And you'll have a key that looks like this. And you'll put 1/2 in and then hit this key and then put in 9, and it'll give you the answer there, and multiply that by 3. And you'll get 3 over 512 for an answer for that one. Okay? All right, let's keep going here. And let me put up my formula again. A to the n equals a1 r n minus 1. Okay, so example 5 says, find the general term. Okay, so it's saying find the general term. So it's asking you to use the formula right here, and we'll make a little bit of changes in it. But it says use the... let's go ahead and skip example 5. I'm not going to get into that much detail here at the end of the year. I'd rather get into some other stuff. And I'm going to give you another formula here. So you've got the general term formula, and let's look at the sum of the geometric progression formula. And that looks like this. All right, so the sum of the geometric term formula, which is what I have there, is basically if you were to take all the numbers that they give you and add them up, what would that answer look like? So for example, we'll look at example 6. So it gives us these set of numbers. Okay, and I'm going to go and write what I've got. A1 equals 5. R, my ratio, is going to be a 3. And that's pretty much all I need there, right? Okay, so let's see what we've got. It says find the sum of the first 10 terms. So this n here is going to be a 10. My first number is a 5. My r is a 3. My n, again, is a 10, minus 1, over r, which is a 3, minus 1. Okay, so there's my formula. So 5, I've got 3 to the 10th power. I have no idea what that is, but you're going to use that y to the x key right there. So you're going to put in the number 3, hit this button, hit 10, and it will give you some huge number. And you'll take that and multiply it by the 5 and put it over 3 minus 1 is 2. And you're going to get an answer of 147,620. And that's pretty much it for that. I will be at school, so you're not going to really need me to go over a bunch of examples. So if you have any struggles, you can just find me. But that's it for lesson 13.4.